A critical number is where the function f of x is defined, but derivative of f or f prime of x is either 0 or undefined. Like we have a graph of f below. In this case, we have 1, 2, 3, 4 critical numbers, and one of them is right here because the function has horizontal tangent line at this point. Therefore, f prime of x is 0 at this point. Now this is another critical number because at this point derivative of f is 0. This point is another critical number because at this point derivative of f becomes 0. As we are getting closer and closer to this point, the tangent line becomes the horizontal line, which means the slope of the tangent line at this point, at this number is 0, or f prime is 0. Now, this point, as we're getting closer and closer to this point, your tangent line is becoming vertical, or the f prime is approaching infinity, or f prime is undefined. F prime is undefined at this point. So this is another critical number or value, however you want to say it. Now, what's important about critical value or critical numbers is the relative extrema. It implies, or relative extrema can only occur at critical numbers. Like in this case, you have a relative extrema, you have a relative maximum in this case, and you see this point is a critical number. This case, you have a relative minimum, and you see this case, you have a critical number. In this case, you have a relative maximum, and you see you have a critical number at this point. But it's important to realize that the converse of this statement is not true. Just because a function has critical number at some point doesn't mean it has relative extremum, relative maximum, or relative minimum at that point. In this case, you have a critical number, derivative of f is 0, but you see this point, at this point you don't have relative maximum or minimum.